Hi, grade 7. This is day 13, lesson 9-1A, page 419, numbers 4 to 11, all of them. Before we get started, in a few seconds, I'm going to ask you to pause this video and read carefully the page number 418. Go ahead and pause. Okay, welcome back. Let's take a look at problem number 4. Problem number 4 says, what percent of the tree diameters below are from 4 to 9.9 inches? From 4 to 9.9 inches. As you study that table on page 419, you'll notice that 4 through 9.9 actually covers 3 lines of data. Now, I'm not going to do this problem, but I'm going to do one very similar to this. What if instead of 4 to 9.9, it said from 2 to 7.9? From 2 to 7.9. How would we solve this particular problem if we were looking for the percent of the tree diameters that were from 2 to 7.9? Now, the first thing I would do is I would take those numbers on the far right side and I would add them up. In this case, they add up to equal 111. Next thing I would do is I would look at the table and think about what are the numbers that are between 2 and 7.9. Excuse me. And those are the numbers of 6, 30, and 28. I would add those numbers up, and I would get 64. So there are, according to the book, 64 that are between 2 and 7.9 inches, and there's 111 of them that are in all, so to speak. Now, remember, our goal is to change this into a percent. It says what percent of tree diagrams. And so the next thing I would do is I would create a proportion. I am comparing the amount of trees that are between 2 and 7.9 inches to the total amount of trees. This is the portion, this is the whole. I would then grab a calculator and I'd solve this proportion. In this particular case, I get 57.7 approximately, rounding to the nearest tenth percent. My x value in this case is 57.7%. So in other words, if the problem was find out the percent of trees that are from 2 to 7.9 inches, the answer would be 57.7. I'm going to give you a hint on this problem number 4. The answer is somewhere between 70 and 80%. That's the number you're seeking. Let's move on to number 5. Number 5 says the list shows weekly allowances, and they've got what? 5 columns and 5 rows. They've got 25 different allowances there. Organize the data into a table using the following intervals. Well, the following intervals are what? We've got 2.00 to 2.99. In other words, $2 up to $2.99. $3 up to $3.99, $4 up to $4.99. I wonder how high we're going to have to make this table. If you look at the table, the biggest number on the table appears to be $10, so I better keep going at least to beyond the point of $10. And we're going to create, as neatly as we can, some columns and some rows. And let's see. Oh, we should probably have tally up here. And then frequency, right? Because that's typically the way this kind of a table works. And then it says, let's see, so this is still 5a. Well, how many numbers are between 2 and 299? I only see one. How many are between 3 and 399? I see 2. How many are between 4 and 499? I see 5. And for 5a, you need to finish off this table. And then in 5b, it says, what is the most common interval? Well, you're looking for the one that has the largest number in this frequency column, and you're going to write down the interval that has that largest number for 5b. Okay? Let's move on to number 6. The oldest magazine in the United States was first published in 1845. If 12 issues were published each year, how many issues would be published through the year 2005? This is a problem where you really need to be careful because the temptation is to just simply take 2005 and subtract from it 1845. In this case, we get 160 years, and then say to yourself, boy, that must be 12 groups or 160 groups of 12 issues of this magazine. Because that's what it's saying, right? It's saying that they publish 12 issues every year. So the temptation is to take 160 years times 12 issues and see what answer you get. Now, why is this not the right answer? Why is 1,920 not the right answer? Well, let me show you with a simpler problem. What if this company started in business in the year 2000 and finished in the year 2005? How many years did they publish magazines? Well, at first glance, you might be tempted to say 5 years. But it's not really 5 years. Why not? Well, think about it. They published in this year, this year, this year, this year, this year, and this year. That's not 5 years. That's a total of 6 years. So you end up having to subtract these two numbers, but you've got to add an additional year because the first year doesn't get counted when you just do the subtraction. And so up here, when you do this subtraction, hint, 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 we're not really counting the year 1845 in this circumstance. So there's really not 160 years of publishing this magazine, but really 161 years. That's the big hint on this problem. Number 7, in a recent survey of 120 students, 30 students said they play baseball and 60 said they play soccer. If 20 play both sports, how many students do not play either baseball or soccer? Any idea how you're going to solve this? I hope in your brain you're thinking Venn diagram, because if you are correct. We have two intersecting circles. One of them represents baseball. One of them represents soccer. Remember, on these Venn diagrams, we always start in the middle. So what number do we put in the middle because people are playing both baseball and soccer? If you said 20, you're right. Now, they surveyed a total of 120 students. And the problem says we want to figure out how many students are out here. The amount of students who don't play soccer and don't play baseball, right? What else do they tell us? They tell us that 50 students are playing baseball. If 50 students are playing baseball, can you tell me why it would be wrong to put a 50 right there? Well, because 50 plus this 20 makes 70. The 50 they're talking, the problem is the total amount of students. So we really need to put a 30 there instead of a 50. Now we've got 50 baseball players. What about soccer players? Well, if they said that 60 kids play soccer, would it be right to put a 60 here? No. 60 and 20 makes 80 soccer players. We want 60, so we're going to put a 40 there because 40 plus 20 is the 60 who love soccer. So if 30 play only baseball, 20 play both sports, and 40 play only soccer, how many are left that play neither sport if the total amount of students that were talked to is 120? That's your big hint for number 7. Let's move on to number 8. Number 8 says, name 3 countries that have a combined forest area of approximately equal to that of Russia. If you look at the chart, Russia is 3.3 million acres of land. How are we going to solve this one? Well, you are going to look for the names of 3 countries that when you end up their land equals that 3.3 that Russia is talking about having in our chart. We need the names of 3 countries. So for example, maybe your answer is going to be something like Canada, Brazil, and China. If those 3 countries' numbers add up to about 3.3 million, then that would be your answer. Let's look at number 9. It's a pretty easy one. At least I think it will be. Dexter's brother wants to buy a used car. The list shows the model year. Which year is listed most frequently? All you have to do is go through that data table, set up a situation where you can figure out how many of each year appears, and figure out which year appears most often, and then write that down. Let's go to number 10. The average salary of an NBA basketball player is $4.5 million, and the average salary of a WNBA player, which is women's NBA player, is $43,000 per season. About what percent of the NBA player's salary is the WNBA player's salary? Well, let me show you an example of a problem that's similar to this, but it has different numbers. What if I told you that the NBA players, instead of the number they wrote, had a salary of $3 million, and the WNBA players were having a salary of $60,000? And I said to you, what percent is the the WNBA player's salary compared to the NBA player's salary? Well, here's what I would do. I would create a proportion in which I'm comparing the WNBA to the NBA, and since we're dealing with percents, I'd make it equal to X over 100. WNBA compared to NBA, X over 100, and I'd solve this proportion. In this particular case, let's get the calculator going here. 6. In this particular case, I get an X value equal to 2%. An X value equal to 2%. Now I'm going to give you a hint about your particular problem. When they say $4.5 million, remember that that means $4,500,000. That'll make it easier for you to think about this. And the WNBA player is, of course, still $43,000. Okay, let's take a look at the last problem. What are the dimensions of the rectangle if the rectangle has an area of 24 and a perimeter of 22? I'm going to give you a big hint on this one. You know, hopefully, that area equals length times width, and you know that perimeter equals length plus width plus width. So if that's true, and if we're told that the area is 24 and that the perimeter is 22, what you need to do is try out each of those answers in our two formulas and see where it comes out to being true. I'm going to pick randomly one of these. I'm going to pick 6. 6 and 4. In other words, I'm looking at answer choice B. Is that the answer to this problem? Well, 6 times 4 is 24. That's true. But if I add 6 and 6 and 4 and 4, I do not get 22. Instead, I get 20. So answer B can't be the answer. I'll let you figure out how to solve it on your own. Thank you and have a good day. If you get stuck, give me a call. You know my numbers, 517-242-3138.